So here we're going to find the inverse by using the convolution theorem. And yet again, we could use partial fractions and probably would be able to get through it reasonably quickly. But again, just illustrating the use of the convolution theorem. So looking at this, I'm going to break this up into two other transforms. And I'm noticing that I have an s squared plus 4, which I know I'm best suited if I put a 2 in the numerator. So that leaves 2 over s squared, and this is actually quite nice because 2 over s squared corresponds to the function 2t, and 2 over s squared plus 4 corresponds to the function sine of 2t. So now it's a matter of figuring out, when I do the convolution integral, which one do I want to get the t minus w? And it seems as though this would be the easiest one to plug that into because this would require an identity. So we're going to say 2 times t minus w sine of 2w dw. Now, in order to find this integral, now one thing we could do is break it up into two integrals, but there's really no need to do that. I'm going to use integration by parts here, and I'm going to say, because even if we broke it up, one of them would have to be integration by parts. I'm going to say u is equal to t minus w, and dv is equal to 2 sine 2w. Kind of thinking a step ahead, I know when I take the antiderivative of sine to 2w, I'm going to end up with an extra half. So if that 2 is there, that'll absorb it. So that means that du is equal to negative 1 dw. Remember, differentiating with respect to w. And integrating with respect to w over here gives me negative cosine of 2w. So with this integral, we now have u times v, so it's negative t minus w, cosine of 2w, and that's going to actually be evaluated at the endpoints t and 0, minus the integral from 0 to t of v du. So that's negative 1 times negative cosine 2w dw. And the first thing I notice right there is I have a minus, 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 which means two of the minuses can go away. So I'm actually going to take this away, take that away, and that's going to be oh so much easier to handle. So now evaluating at the endpoints here, so we have negative t minus t cosine 2t minus negative is plus t minus 0 cosine of 0. And then over here, the antiderivative is, well, now I can't avoid the 1/2, so 1/2 sine of 2w evaluated at t and 0. So let's see here, t minus t is 0, so this whole term, whoops, I didn't mean to actually do that. This whole term just goes away. And over here we have t times 1, so that's t minus. Evaluating this one, now at t we have minus 1/2 sine of 2t, and then evaluating at 0, that gives 0 over there. So there is our original function. Y of t is equal to t minus 1/2 sine 2t. And there is, again, finding an inverse using the convolution theorem. Thanks for watching.